We are extremely delighted to have every one of you here today, uh, joining us for this exciting journey into the world of containerization and Google Cloud. So we are extremely excited to share with you all the important things that would be certainly helping you on your journey to understand Google Cloud in a much more deeper sense. So before we start, let me just quickly introduce all of us over here from SkillUp Online ourselves, what SkillUp Online is. So if we talk about SkillUp, who we are. Now, let's just take a moment to understand who we are. SkillUp Online, we are basically a career-focused online learning platform. It's not just about a learning platform, it's a community which is committed to closing the tech skills gap. So our goal is simple: to empower professionals and organizations to thrive using emerging technologies. So we believe in the power of personalized learning, offering job-aligned future skills and practical experience to bridge the ever-growing skills gap. So whether you are a tech professional who's looking to extend your skills, a career starter who is looking for some entry-level roles, or if you are a career switcher seeking a new path, or maybe a career returner ready to upskill after a break. So SkillUp Online has a tailored solution for everyone. So our offerings include job-ready skills that focus on exam preparation, placement services, personalized mentoring, active learning community, practical experience, global certifications, blended learning, and up to the mark courseware, and of course human skills training. So we focus on providing not just technical expertise, but also finely tuned soft skills, which are equally important in both professional and personal life. So why would you choose SkillUp over any other learning platform? So through our human-centered approach to learning, we empower you to fulfill your professional and personal goals, and definitely you can enjoy your career success. So whether you're reskilling into tech, you're upskilling for a promotion, or cross-skilling for your career, we are here to guide and support you. So this is quickly about what SkillUp is and who we are. So currently we are present in USA, Europe, and India, and we in 2024 we are also into Portugal. So we are providing our services. We are delivering trainings across the globe. These are just a few cities and few countries to mention. So far, the learning content that we have developed spans over 5,000 plus hours of content. Uh, as I already mentioned, we are over 3 continents, so definitely a global presence. And then we have so far, since the inception, we have trained more than 500,000 enrolled users, and there are multiple, we are working for multiple universities. We are providing some upskilling courses in the B2C market in across the globe. We are also working along with the industries to train their employees. So this is just a brief information introduction about SkillUp. Now, as I already mentioned, why would you choose SkillUp over any other platform? Is what features do we provide? So it's about personalized mentoring, best-in-class course content, practical exposure, experience, and then hands-on, hands-on learning with our esteemed mentors. So this is all what SkillUp has for all of you. Right now, without taking much of your time, let us just quickly welcome our instructor for today's workshop. So let's meet our expert, Mr. Parth Kumar. So Mr. Parth will guide us through the intricacies of this app containerization on Google Cloud. So welcome, Mr. Parth. To give you all a brief introduction about Mr. Kumar. So he's a seasoned cloud solutions architect with extensive experience in designing and implementing scalable cloud architectures. Mr. Kumar is also a certified Google Cloud professional architect and has successfully led multiple projects in the domain of containerization and microservices. So, a very warm welcome to you, Mr. Kumar.
Thank you. Thank you, everyone.
Before you start your session, let me give you all a quick outline of the whole session. So today's session will be led by our industry expert, Mr. Kumar, who will be providing you all a comprehensive comprehensive overview of app containerization. We will be talking about Kubernetes and microservices and all. After that, we will be looking at the program overview that SkillUp has to present to you all. We will also have a gamified quiz towards the second half of the session, and then towards the end, we will have this Q&A session. So throughout the session, just in case if you have any questions, please feel free to put your questions in the chat, and Mr. Kumar will be there to answer. Also, it will be good if you, stay towards, I mean, you have some questions, please note it down, just in case if it is not convenient to answer during the session, we will certainly take that towards the end. So we have a dedicated time for the Q&A session towards the end. So yes, stay tuned for this engaging and informative workshop. Over to you, Mr. Kumar.
Yeah, thank you, everyone. So I welcome you all to our, app containerization session. So let me share my screen. Let me check. I hope you guys can see my screen. If you guys can see my screen and also can hear my voice properly, just put yes in the chat. Just put yes in the chat if you guys can see my screen and also my voice is pretty clear. Just put yes in the chat. Perfect. Thank you. So what are we going to learn in this 1.5 hour session that we have? We'll be talking about first, what is an app containerization concept? How can you convert your application, a traditional application, into a containerized application? Then we'll go through what is a microservice, overview of microservice. Then we'll understand how do you manage your microservices using Kubernetes. We'll also see a demo, how do you convert your application, a traditional application into containerized application. And then last, we'll see a demo also, how do you deploy your containerized application on Kubernetes. And we'll talk about a few more things about the GCP infrastructure and the capabilities we have in order to host the containerized application. Let's start with the first one. What do we understand by the app containerization? Just wanted to check, anyone has worked with app containerization? What do we understand by meaning of container? What is the meaning of app container? Anyone? You can unmute yourself. You can let us know what is the meaning of the containers. Have you worked on that? Do you have any experience? If you don't have it, you can simply say, no, I don't have any experience. All right. What is the meaning of app containerization? When we have to understand containers, we need to understand three terms. One is, what is a container image? What is a container? And what is a registry? If we understand these three terms, container image, container, and the registries, we can easily get into what do we mean by converting your application from a traditional application into a container-based application. I'll be using this particular tool, which is appdiagrams.net, to explain you the concept. We'll go with a very simple example. Let's say I want to deploy a very simple application that is written in Python. I want to deploy that on a machine. Now that machine could be on my laptop, that machine could be a bare metal, that machine could be a machine in the Google Cloud. Now I want to deploy an application. I want to run that application on a machine. It's a Python application. If I have to run this application on this machine, on this virtual machine, in a traditional approach, what I'm going to do is, the very first step I have to do is, I have to install Python. That has to be the first step. Install Python on machine. That has to be the first step, install Python on the machine. Once you install Python on the machine, then and only then you're going to run your application. But your application might be talking to a database. In that case, there would be certain dependencies in your application. For example, if your application is written in Python and let's say the database is a Postgres database, in that case, you will be installing a module by which your application will talk to the Postgres database. I'm just adding some more complexity in my application. Initially, I started with just a simple Python application. Now I'm saying that my application is going to connect to a database. If my application is going to connect to a database, that means I have to now add module to connect to DB. Add module to connect to DB. That's a second dependency. So in order to run an application which is written in Python on a machine, and that is talking to a database, I at least need to have Python on this machine and the dependency, which is a module by which I can connect to the database. Similarly, if my application is talking to another, it is more dependent on, there are a few more modules that I'm using in my application. Maybe I'm talking to external interfaces. Maybe I'm doing some file system things, or maybe using some libraries. I'm doing some operations in my application. I need to ensure that all of these modules must be present on my machine. Then and only then I can run my application. And this is what we call as a traditional way of doing the things. We take a machine, we install all the software, so we install all the dependencies, and then you can run your application. What if I say I can run my Python application on a machine wherein we don't have these dependencies. The dependencies are not present. But still, let's say this is a machine number 2, I can go and run my Python application. And this application is also talking to a database. The same thing that I did in the previous machine, I can do the same things here. My application is going to run, is going to connect to the database. The only difference between the machine 1, which is the first machine, and the machine number 2 is on machine number 1, I'm going by the traditional approach. That means I have to install the Python first, and then I have to install all the modules. But in machine number 2, I will not install any dependencies. Still, I will be able to talk to the database. Still, I will be able to start my application. Still, I will be able to process a request. How is that possible? And that's what the benefit a containerized application is giving you. On machine number 2, I can still run my Python application without worrying about whether these two dependencies are present or not. This is the core of your containerization, what a container application gives you. So when we have to learn containerized application, we have to understand 3 terms. One is container image. Then we have containers. And then last one, we can talk about, what about the registries and all. And there is also one more term I want to talk, which is known as container runtime. So far, I just talked about that, without installing these dependencies, you will be able to run your application. And that is only possible if it is a container-based application. But how is this happening? How is this possible? You can run a Python application on a machine, but without installing Python on that machine. You can run a Python application and connect to a database without installing the modules on that particular machine. How are we doing that? And that's where the containerized comes into the picture. If your application is a container-based application, you will be able to fulfill this. But what is there in the container? How is it able to do? How is it able to run an application without the proper dependencies present on that machine? And the answer lies with these three terms. If we understand what is a container image, if we understand what is a container, we understand the whole criteria of how an application can run without having any dependency. So first thing is, what is a container image? Let's say this is my application code, wherein it's like a abc.py file, a simple Python file. You can take it, the people who are from the Java background, they will think about this as jar files or a combination of multiple jar files. So I'm just giving a very simple example with respect to a Python. Let's say this is abc.py file. If you want to make your application a containerized application, the first step has to be create a container image from your application code. That's our step number one. Step number one has to be, from your application code, generate a container image. Now, what is there in the container image? A container image basically is a package. Is a package that has your application code plus all it is dependency that you need in order to run your application is part of your container image. It's a package wherein you're going to put your application code along with all the dependencies that are part of your application. For example, I've just shown you one file, which is abc.py file. This means when I'm going to create a container image, I'll be having this abc.py file within this container image. If I have lots of files, probably when you write your full-fledged code in let's say in Python, you will be having modules, you will be having packages. Everything is going to get into the container image. Along with that, so your application code is part of your container image. Along with that, you will be having all the dependencies part of it. Now, in our case, because I'm just taking a simple example, dependencies are, I need to have a Python present on this machine. Plus, I need to have, let's say if my application is talking to a database, so I'll just write here DB module must be present within the image. So in short, if I just give you a very simple definition of what is a container image, it's a combination of, or it's a package that includes your source code plus whatever dependencies you need in order to run that source code must be part of your container image. Once you create your container image, the next step is you have to run your application. Container image is a static information. It's just a package, a static package that has the files and the respective dependencies. But if you want to send a request, if you want to process your, if your application wants to process something, it has to be in the running state. That running state is known as runtime state of container image, is known as a container. So from your container image, you're going to create something known as a container. So step number one, if you have to, move towards a containerized application, you go your traditional code, you generate a container image. This is your step number one. From container image, the step number two would be to generate a container. Now, container is representing your execution environment of container image. These are the terms that we use, execution environment of container image, or in simple term, your application has to be in the running state in order to, in order to process any request. To make your application in a running state, you have to create a container. This is your step number two. Once you create your container, within that container, your application is running. So for example, if it is abc.py file, that means within this container, there would be a process which would be running for abc.py. Once your container is up, maybe it's also, or you would need a machine as well to run this. Let's say this is a machine wherein you are running your container. Now on this machine, where I'm running my container, maybe on this machine, I'm saying maybe the Python may be present on this machine. I don't care. Maybe the Python is not present on this machine. I don't care at all. Why? Because whatever is required is already part of the container. The Python is already there. That's what is there in the container image. The DB module is always there because my application is talking to a database. It's already part of the container image. So when this container will run on a machine, it will never, your application process will never go to your operating system to see whether the dependencies are present or not. Whatever it needs, it will always try to get it into the container only, within this container only. So it requires Python to start this application. The Python is already within the container. It needs this DB module, is already there within the container. This way, what are we trying to achieve? We are trying to achieve that you're making your application completely abstract from the environment where you are running your application. This abstraction is the main backbone of the containerized application. But how is this going to get benefit us? I can still go and run my application in a traditional way. What is the point? I'm just running the same thing, maybe within some containerized restricted environments. What is the process or the profit that I'm getting? Why will go with this approach? Why not go with the traditional approach? The reason being is the main idea was, to go into this direction of containerization was a lot of times what used to happen is typically a developer who used to work on his machine may be using the latest softwares. And the softwares that are there in the production machine will be different. For example, let's say, we as a developer, we are making some software and there are multiple clients for that software and each one is having their own Java version. Now I cannot install each and every Java version on my machine, but I'll be having the standard latest Java version on a machine and I will do all the coding by using that Java version. But it could be possible that if you have written your code, maybe the latest Java version, or let's say the Python version is 3.9, and in the production, the Python version is still 3.5, there are chances, high chances that your code will break. And one of the common scenario would be that you might be using some libraries from Python 3.9, but in production, it is still 3.5. So those libraries will not be present. I will pause for a moment to see anyone having any questions here till this point. This will take a couple of questions. Anyone having any questions till this point? You can put your, if we are good to continue, you can put good to continue so that we can, maintain the space. Just looking for the answers in the chat. Good to continue. That's great. Cool. So we're talking about how you can, create a container image. From a container image, you're going to create a container. And what are the benefits? The benefits is, as I said, this was happening. You may be using one version of the software, but when you deploy your application on different environments, having different software versions, Java minor, major version, Python major, minor version, or the operating system dependencies, they're used to create problems because of the environment mismatch. And container-based approach, tries to rectify those errors. It makes your deployment very, very seamless. What it guarantees is the configuration you are using on your local machine will be always the same you are using it on the production machine. That is what it is guaranteeing. If you are using on your local machine or on the development machine is Python 3.9, it will always run with 3.9 on any machine, whether that machine could be on your local machine, it could be staging environment, it could be development environment, it could be your AWS machine, it could be your GCP machine, it could be your Azure machine, any machine. What it ensures is that it will always run with a Python 3.9. And why is that so? That is because of this container image. And it gives you flexibility as well. For example, let's say I'm a developer here, this is my machine. I have created a container image of my application. This is a container image of my app. I can run the same container image on different machines. Maybe one machine is there in cloud on AWS. I can go for it. Other one is there in, let's say GCP. I can run this. Now, in order to run the same application, which is there in the container image on different machine, what I need to do? The first thing I need to ensure is I need to ensure on these machines, this image should be present. Let's say by somehow I'm able to manage, I'm able to push this image on these machines as well, the same container image of my application. I'm able to push this somehow, I'm able to push this on these machines as well. What is the next step I need to do? The next step is on these machines, I need to have something known as a container runtime. Now, container runtime is basically the software that is used to manage these container image, that knows how do you generate a container image from your application code. Software that knows how do you create a container from a container image. Software that knows how do you start a process, within a container. Software by which you can stop a container. Software by which you can start a container. Software by which you can go inside the container. So container runtime, I'm just adding one more term here. Okay, I already written here on the notepad. So container runtime is the software used to manage containers, container images, and containers. One of the most dominant one in this area is Docker. So Docker is an example of container runtime. So I defined container image. That means your application code plus all the dependency. I said container, that is a runtime execution of your container image. Now I am defining the term that is container runtime, which means the software used to manage your container images and the containers. What you need to do is, if you want to have this kind of scenario wherein you have created your application on one machine in containers and you want to run that on different machines, you need to have container runtime on these machines as well. So on this machine, I need to have Docker present. On this machine, I need to have Docker here as well. And on my machine as well, I need to have a Docker. Once I have the container runtime and the container image, I can run my application on these machines as well. That is what the container runtime is going to help me. That, okay, you have the image. Now from the image, let's create the container. This is my app container here. And the same thing, I'm going to do it on the machine of the GCP. On this AWS machine, doesn't matter whether on this machine Python is installed, doesn't matter whether the database the DB module is present or not. Why? Because everything that needs is part of the container image. So that is the first part of our agenda today, that we need to understand what is app containerization. In that, we have to cover these three concepts: app, container images, containers, and the container runtime. The last thing I'm going to talk about container is, before we go for a demo, I said somehow I can, somehow assume that my container image is on this machine. But how are you going to ship your container images from one machine to another machine? And that's where the fourth term comes into the picture, which is registry here. So it is basically a storage for container images. So you would ship your image from one machine into a container registry. So you will push it from one machine to this registry. And then from another machine, you will pull it. So one side you have to do push, other side you have to do pull. This way, you can ship your machines from one place to another place. Some of the examples of container registries are, one of the common one is a Docker Hub. Very common. common one. If you could just go to the internet and search for Docker Hub, you will see lots of container images are there. For example, if you go to the internet and search for Docker Hub, you have it's a library, container image library, and there are already images. For example, let's say you want to run a Postgres on your machine. There is an image already available here. You can see a Postgres. Let's say you want to, uh, do some hands-on on the operating system, Ubuntu operating system or Linux operating system. You can just have this image, start this image on your machine, and you can straight away start learning Ubuntu. Or you want to have a MySQL, or you want to have, let's say, typically if you want to install Postgres, you need to first install Java. But if you go via the container way, just a couple of commands and your Postgres will be up and running in your machine. So Docker Hub is an example of a container registry. What else? There are each and every cloud player has their own container registry. For example, Google has something known as GCR, which we also call Google Container Registry. AWS has ECR, which we call as Elastic Container Registry. Similarly, Microsoft has its own container registry. Each and every public cloud player, they have their own container registry, wherein you can push your images. Then from different services, you can pull the images. So Docker is an example of a container runtime, as I said. For those who are looking for what does Docker mean, Docker is basically an example of a container runtime. It's a software that is used to manage your container images and the containers. Now let's see a demo on this. Whatever I said, we'll see a demo on this. I have a folder here. This folder has 3 files. I'm opening this first file, which is a Python file in my notepad. Now, we don't need to focus on the code here. The idea is not to make you understand how the Python code is. This could have been written in Java. It could have been written in PHP. This could have been written in Node.js. So we don't need to focus on the language here. Rather than we need to focus on the behavior of this code, the functionality of this code. So this code is basically a Python code written, exposing a REST API. The API is on /welcome. So that's an REST API /welcome. Once this application starts, our application will listen on port 3000. And then I can send a request on /welcome, and I should see output welcome to the container world. Now, if I have to put the dependencies in order to run my application, which is Docker first app, if I have to just mention the dependencies, the very first dependency is I need to specify the Python. Because it's a Python code, I need to have a Python present on my machine. The second dependency, as per this code, is here we have written Flask. Now, again, as I said, we don't need to get into these special libraries. The reason being is we don't have to get into the language. But for those who are concerned about what is this is what makes your application a REST application. So Flask is a module in Python by which you are making your application a REST application. So as per of the dependency is concerned with my application, one is Python, other one is the Flask module has to be present. Once these 2 dependencies are there, then and only then I can run my application. Okay. Now, if we go by this diagram, in order to create a container image, I need to have Docker present on my machine. The Docker is already installed on my machine. This is how a Docker looks like. You can install Docker on Windows as well. Typically, by nature, Docker is for the Linux, but there are certain plugins you have to install while installing the Docker on the Windows as well. So this is how a Docker looks like. Once you install your Docker, I've already installed Docker on my local machine. So the container runtime is present on my machine. The application code I have shown you here, which is in this folder Docker demo basic. Now I will run this application via a Docker, by going through the Docker approach or the containerized approach. So I'll open the CMD and I will run certain commands. Docker, which is the container runtime, is giving me certain commands by which I can, create a container image. And then from the container image, I can create a container. First, let's focus on this container image. If I type a command which is known as docker space images, if I type a command docker space images, I can see what all container images are there. There are lots of container images already present on my system, but we're going to create a container image of my application. Now, there is a question here in the chat. Let me take that. Can we store a custom image and build according to our requirement, or is it something which is already in one form? We can store a custom image. It's not about storage. It's about, can we create a custom image as per our own requirement? Yes, that completely depends upon how you want to, or what things you want to package within the container image. Completely up to you. You can define, and there are the steps by which you can do that. So there is a file which is known as a Docker file. If you can see that this Docker file is there also in my directory. This Docker file has all the steps, what things should go within a container image. And you have complete control on that. All right, so coming back on here, if you do Docker space images, you can see what all images are there in your, on your machine. There are a few images already present on this machine, but we'll be focusing on our application. So we will create a container image from scratch. To do that, we need to run a command which is known as docker build. This is the command, docker build -t, your container image, and the dot. Dot means in the current directory where your Docker file is there, I'm going to create a container image. This is the name of my container image. Right now, if you see the output of Docker space images, you don't see any name with this name, my first app image. But once I run this command, I'll be generating a container image of my application. I'm in this folder, which is Docker demo basic. If I do a dir, I can see what all files are there. There is a Docker file. There is my application code, which is docker first app.py, and there is something known as a requirement.txt. Let me go and run this particular command. I'm generating a container image of my application. Once the container image is generated, if I say docker space images, you can see now my first app image is there. That means this particular image is representing my container image of my application that has the source code plus all its latest dependencies, plus all its dependencies are part of it. Once you have the container image, the next step is you're gonna create a container. That's what we said. From a container image, we need to create a container. So we are now in the step number 2. To do step number 2, you have to do docker run. And you have to pass the container image name using the -d flag. My container image name is my first app my first underscore app underscore image. The flag that is -- name specify that what is the name of the container you are going to give. In my case, I'm giving the name as my first app. That means this container that's going to get created will have this name. And then I'm saying that my container application process is going to get exposed on the port 3000. Let me run this particular command. Now, if I do Docker space PS, now Docker space PS will give you all the running containers that are there on my system. You can see there is a container with the name my first app, and it is created from the image that is my first app image. Now let me test my application. In order to test my application, what I need to do is I will go to the browser. I will say localhost colon 3000 slash. What is the API that I have exposed? It is slash welcome. And you can see the output. Welcome to container world. This application right now is running within the Docker container, within this container. I can stop this application. I can stop my container as well. There is a command. I can say Docker stop, and I can give this container ID. When you stop a Docker, and when you stop your container, it means your application is also stopped. Now, if I do Docker space PS, I don't see any application running. That means the container is stopped. That means my application is also stopped. If I go back here and I say localhost colon 3000, maybe I will take a new tab. You can see I'm not getting the output because the process, the container that was running behind the scene, I have stopped that container. I can start that container again. If I do Docker start, and I will give the container ID or the container name, I can start the container again. Now, if I do Docker space PS, I can see the container is back running. If I go to the UI and just hit a request, I'm getting welcome to container world again. So this way you can convert your standard application into a containerized application. So that was our first part. That is, what is a container? What is container image? What is container? What is the registry? And this is typically a bigger picture of how you should deploy your application. You need to have your infrastructure, your machine. On top of that, you will be having your operating system. On top of that, you will be having, here the example is Docker, but in general, it could be a container runtime. There are other examples of the container runtime. And on top of that, you run your application in terms of containers. So these are the different applications that are running here in terms of containers. Right now on my machine, there is only one application running in terms of containers, which is my first app image. Now, going further, we'll be talking about the microservices. Now, when we have to define microservice, we typically use, these two kind of definition. One is monolithic architecture, other one is the microservice architecture. Monolithic architecture stands for a big code base wherein all the layers are tightly coupled. For example, you may have a code base wherein you have your UI code, your business layer code, your DAO layer code, everything part of the same package. Now, if you want to visualize this, maybe people who are from the Java background, you can think that these are the different packages of the same jar file within a same jar file of a Java project, or each package may represent different jar file, but when they are going to get deployed into the production machine, it will be always all the jar file will get deployed into the same time. That means a single JVM will be there. So it's a single deployable unit. That is important. So in a monolithic architecture, typically what was happening is when you deploy your application code, you deploy that as a single deployable unit. Everything will goes with that single deployable unit. User interface, business, DAO. Now it could be different functionalities, whatever you have, they're part of the single deployable unit. Now think about a case wherein you may need to do a small change, maybe a logger change in your business layer, a small logger.info change. And you have to redeploy the whole package again, the whole deployable unit. The user interface need to be deployed, the business layer need to be deployed, the DAO interface need to be deployed. And a lot of times we used to get problems because of the redeployment of the whole software. You have to restart your application. Probably you may be exposing some environmental variables. You have to just set those environmental variables again. And again, not only this, but you have to go through the whole testing cycle, because for testing, guys, it's a complete black box. You are just doing the change in the complete package. And that's why we say, let's not go with the monolithic, but let's go with the microservice, wherein you divide your application into smaller deployable units. For example, you can have a component that is just representing UI. You can have a component that is just representing the CLI functionality. You can have a component that is just representing your business layer. You can have a component that's just representing your DAO layer. You can have a microservice that is just representing your external interfaces. Each of these microservices, you typically create different repositories in the GitHub. But what is important is each of these microservices can be deployed separately in the production machine, can be started separately in the production machine, can be stopped separately in the production machines. This gives you the flexibility that if there is a change, maybe just a logger change in one of the business layer, only that particular microservice will be redeployed. So the testing will only go for that particular microservice. But yes, on a whole, if it has to be part of an integration testing, you will test the complete integration stack. But from functionality point of view, for that particular microservice, it is just you will focus more on that particular microservice. And you can also do the development parallelly. Maybe microservice UI can be developed by a different team. Maybe microservice backend can be developed by a different team, because they're totally independent of each other. One of the ways how these microservices talk to each other can be via the REST API call. And nowadays, you can write these microservices without containers, or you going by the traditional approach. But nowadays, we are writing these microservices. The development is going more into the microservices with the containers. And the reason being is containers gives you that flexibility of moving your application from one machine to another machine without any dependencies on the operating system. And you can start your containers as fast as possible. And it is giving you the isolation as well. So nowadays we have started writing these microservices into containers. And that's what we say, microservices are basically an architecture style that develops a single application as a small set of services. Each service runs its own processors. And typically how you're going to communicate, one way of doing that is a REST API or an HTTP protocol. It could be also possible that different teams are working on different microservices. Maybe one microservice is written in one language, maybe another microservice is represented in another language, maybe deployed on a different network. Might be possible. So that's the flexibility you will be getting with these microservices, dividing your application tech stack into, or your features into different small deployable components, gives you the flexibility of the parallel development, fixes. You can fix your bugs quite easily, deploy things quite easily, and you can scale your application as well quite easily. Now, what is the meaning of scalability here? If you go with this monolithic architecture, if you have to scale your monolithic architecture, maybe on one machine you have deployed your monolithic architecture, you want to deploy it on another machine. Typically, the scalability of a front-end component, a user interface, would be different from the scalability of a backend component. The reason being is, typically your front-end includes your static files, HTML code, JavaScript. They don't have any state dependencies. But if your backend code is typically, talking to the database, so you will be creating the connection pools, DB connection pools and all. So you need to think also how much scalability I can go for the backend. And your front-end scalability is not same with respect to your backend scalability, backend code stability. But if you go with the microservice, you can easily scale front-end code in a microservice separately from the backend microservice. Maybe your front-end code can scale very fast, but your backend code may not. Or maybe the number of instances of your front-end microservice can be more than the number of instances that we have for the backend code. Might be possible, but this you can achieve if it is only a microservice-based architecture. Microservices are good. It's giving you a complete freedom, doing a lot of things in parallel, development, deployment, everything. But there are its own challenges. Now, what are those challenges? And that's why the Kubernetes comes into the picture. What are the challenges with the microservice? In order to explain you what are the challenges, I need to give you an example. Let's say I have a banking application. Now, I would like to highlight certain features of the banking application. I have one feature as accounts functionality, wherein I can do that, withdrawal, deposit. I can have the saving account, current account, whatever types of the accounts that we have. That's one kind of functionality I have in my banking app. The second is, let's say I can go for loan. So I can go for house loan, business loan, personal loans is the another kind of functionality I can have. The third one is I can do the investments. I can have the fixed deposits. I can go for the bonds and all. So this is the third kind of feature that we have in our banking application. Let's talk one more. Let's say we have the net banking. Now, these are the four features that are there in the banking application, and I decide to put them into a microservice action. Typically, when you deploy your microservices, in a real world, you will deploy them in different machines that are part of a same cluster. Let's say I'm using 4 machines for my deployment. This is machine number 1. I'm just giving you a real world picture what is going to have, why these microservices can be complicated. 4 machines, and let's say on these 4 machines, these 4 machines are working in a cluster. On these 4 machines, I want to deploy my banking application in terms of microservices, in terms of containers across 4 machines. Now, consider the horizontal scaling aspect of these containers. Let's say for accounts, I need to have 5 instances. For loan, I need to have 4 instances. 4 containers should be running. So instance means container. 1 instance means 1 container. So 5 containers need to be running. Similarly, for investment, I need to have, let's say, 5 containers or 5 instances. Or the net banking, I would be, let's say, 3 instances. So more instances, more load you can handle. More load your application can handle. Now I have 5 account instances. I want to deploy them across these 4 machines. Let's say on machine number 1, I'm deploying 1 container of account here. So I would say account container 1 here. Maybe the second container will go for the machine number 2. The third container will go on the machine number 3. And the last container, 4th container, let's put it on the machine number 4. Because I have 5 containers, that means one of the machines will have multiple containers. So I'll put it on the machine number 1. So 1, 2. This is my 3rd container. This is my 4th one. And this is the 5th one. So first machine is having 2 instances, 2 containers of account functionality running here. This is my machine number 1. Now, let's say I want to put loan, 4 instances. So I decide to have maybe 1 here, 1 here, 1 here, and 1 on the first one. This is the loan container. One, 2, 3, and 4. I will just draw for 1 more container, 1 more functionality, and that's it. Not much more than that. 1, 2, 3, and 4. Let's take an example of the investment, 5 containers. So let me put here 1. This is for investment container. Investment container here as well. Investment container here as well. Third one. Fourth one. And one of the machines will have 2 investment container. Let's put it on the machine number 2. So 1, 2. So this is our third, fourth, and 5. Now you can see how quickly it can get complicated. So you are having multiple machines wherein multiple microservices are running. Right now, there is no problem. They're running perfectly fine. If they're running perfectly fine, we're happy. The problem comes managing these containers. Now, what do we understand by the managing these containers? Let's say you want to update the code in account container. Updating a code in a container means you have to terminate the previous container. You have to create the new container with the new code. So you remove the previous container and you create the new container from the new code with the updated code. Now, if I have to update the containers, for example, the accounts, I have to log in. First of all, I have to figure out on which machine it is running. So here there are 2 containers that are running. So I will go to this machine, I will log in, I will delete these 2 containers, and then I will start 2 containers here. Similarly, I will log into the machine number 2. There is 1 container. I will delete the previous one and increase the new one or create the new one. Same goes with the remaining 2. Although it can be managed, you can still do these things via script. It can be manageable. But this is still an overhead. How do you update the code within a container? The bigger overhead is, what if machine number 1 goes down? What if machine number 1 goes down and is not coming back? In that case, if machine number 1 is not coming back, you need to move the container that were running on machine number 2 on existing machines. On existing machine, maybe all the containers that were running on machine number 1, you have to put either on the machine number 2, either on the machine number 3, either on the machine number 4. But can I blindly put all these containers that were running on machine number 1 on machine number 2? Can I just go and put all the containers that were running on machine number 1 and put it on machine number 2? If I do that, then you will observe machine number 2 will have 3 accounts container, 2 coming from machine number 1, and already there is a account container running on machine number 2. In that case, machine number 2 will have 3 accounts container, and that's the bigger problem, because now machine number 2 has become a hotspot for account functionality. If machine number 2 goes data down, that means more than 50% requests will not be served because 3 containers are down. So when you have to move the containers from one machine to another machine, you cannot just blindly go and put the containers on the machines. You have to think about what is the best use case I can have so that I don't want to make a container as a hotspot. The another thing is, can the new machine or the existing machine absorb all of these running containers of machine number 1? Does machine number 2 has that system resources in terms of CPU, in terms of disk, in terms of memory? Can it consume all these containers that were running on machine number 1? And you have to do that on the fly. This increases complexity if I just say machine number 1 and machine number 2 goes down at the same time. Now the combinations are increasing. Now think about if it is a very medium-sized project and you may have 5 to 6 machines, and easily it can go around 30 to 40 microservices, then how do you manage them? And Google has been using this this container-based technology is quite a long, and they have thousands of servers wherein they are deploying their application in a container-based fashion, and they cannot use this manual way of managing the containers. That's why Google designed this Kubernetes so that we can manage these container-based microservices in production systems automatically. So that's the use case of the Kubernetes, to manage these containers automatically, no manual intervention here. You tell Kubernetes that you want to deploy your application, you just specify the number of instances, Kubernetes will do that for you. You want to update the code, you will just tell Kubernetes, here is my new update code, go and deploy the updated code. If one of the machine goes down, it's not coming back, Kubernetes knows that what is the best possible solution. I can move these containers to on existing machines, wherein depending upon the CPU utilization, the system resources are available or not. So that's why the Kubernetes comes into the picture. So Kubernetes is a software system that allows you to easily deploy and manage container application. Kubernetes allows you to run your software application on thousands of computer nodes, as if all of these nodes were a single computer. So it doesn't matter behind the scene whether you are having one node, two node, three nodes, 4 machines, 10 machines. For Kubernetes, it's the same. Deploying application through Kubernetes is always the same, whether your cluster contains only a couple of nodes or thousands of them. The size of the cluster makes no difference at all. And that's typically how do you use Kubernetes. That's why you use Kubernetes to manage your container-based application. Multiple microservices, multiple machines are there, and you have to put some automatic way of managing them. You will go for the Kubernetes in that case. Now, when you are to use Kubernetes, what is there is the basic architecture is you will be having a master node. And you will be having a worker node. And this is what we call as a cluster. Master and a worker node is the combination of both is called as a cluster. So whenever we have to work with Kubernetes, we first create a cluster. That means we are creating a master node, we are creating worker nodes. Our application will always run on a worker node. So master node is basically, there are processes that are running on the master node by which you can control the state of the cluster. Our application always runs on the worker node here. So each and every account functionality that I have shown you here, in when you have to deploy the same thing in your Kubernetes cluster, that means for each and every node, there would be one instance or maybe more than one instance running of your account functionality in these worker nodes. This diagram talks about you always work with the master node. So we don't go directly to the worker node and deploy the things. We always work with the master node in Kubernetes. We tell Kubernetes, here is my application code, here is my container image. Go and deploy my container image in the cluster. Go and deploy my application. Go and deploy my containers in the cluster. And these are the number of replicas I want. Replicas is nothing but the instances that I have said here earlier. So you give this kind of information in a file known as app descriptor. You give this to the Kubernetes, and Kubernetes deploy that onto your cluster. Now here on this particular diagram, what we are seeing is the very first diagram, which is the first one wherein it is written 1x. It means I just want to have one instance of this container. So that's why on the right side, you just see one instance here. Then in the second one, we are seeing 5 instances. That's why you see the 5 instances running in the cluster. Typically, here they are representing the worker nodes. Then in the third one, you want to have 2 instances. That's why you only have 2 instances in the worker node. Now, what we're going to do is we are going to deploy our application that we created on our local machine. We are going to deploy the same application in the Kubernetes. So the steps would be, first, as I said, we'll create a cluster in GCP. Now, GCP gives you the managed service for the Kubernetes, which is what we call as a GKE. So you go to the console, you will go for the console and you will say, okay, let's create a cluster. That means you are creating a master node and a worker node. Then you are going to create, or you're going to push your application code to the GCP. And later you will be deploying your application in the Kubernetes cluster as well. The same way we ran our application in containers on our local machine. Now we are going to deploy that application in the GKE. I just want to unshare the screen for one moment so that I can just log into the cloud. Just give me 1 second, one minute max. I'm almost done. Now this is how a Google Cloud Console looks like. This is a GCP console. In this console, there are services related to your compute, there are services related to the storage, there are services related to your network, there are services related to your big data. What we're going to focus on is the Kubernetes. The first step is we're going to create a Kubernetes cluster, which is GKE here. It's a managed service. If you want to deploy Kubernetes, you can do that on your on-premise as well. But then in that case, you have to do all the installation. You have to, create the nodes. You have to install the Kubernetes software over there. You have to do the networking. All those things you have to do on your own. But here, if it is a cloud, you can get a managed service. For example, we have this managed service, Kubernetes engine. We can straight away go on this Kubernetes engine and we can create a cluster. Once we create a cluster, then it is, we are going to deploy our application in Kubernetes as well. So first step is I'm going to create a cluster here. I'll simply say create. Because this is just a demo, I will just keep the worker node as 2 here, just, 2 worker nodes, not much more than that. And I will go for the minimum compute. Now, meanwhile, this cluster will get created. I want to talk about the last point is what are the capabilities you have in the Google Cloud to deploy your container-based application? So the very first capability that we have is you can deploy your application in Kubernetes. Which is the GKE. That is one service. Then you can also deploy your application, which is in Cloud Run. The difference between GKE and the Cloud Run is it's a serverless. So you don't have to provision any server. So if you have to deploy a container-based application, a microservice in Google Cloud, and you don't want to manage the infrastructure, you can go for Cloud Run in that case. But if you want to manage the infrastructure or you already have GKE, in that case, you can go for, or you already have Kubernetes on your on premises and you want to manage them, you can go for the GKE in that case. That is, these are the two solutions you can have for running your container-based applications in the Google Cloud. There is also one more service which is known as App Engine, which is also serverless, but this is more for the customers who are already there on the App Engine standard flavor. App Engine can also run, it's again a serverless compute. You can also run your container-based application here, but the recommendation is if you want to have a serverless, go for the Cloud Run because of the better performance and the pricing. Then the App Engine, this is for those earlier. App Engine has two flavors. One is standard and the serverless. So people who are already there, or the customers who are already there on the standard, they want to move to the serverless, they can go for the from standard to serverless. But for new customers, new applications, the recommendation is go for the Cloud Run for the serverless, or go for the GKE if you already have the Kubernetes cluster, or you want to manage based on the you want to manage the cluster environment on your own. So it will take at least 3 to 4 minutes to get this cluster created. Meanwhile, I will tell you the steps. What we're going to do now is, once we have our cluster created in the GKE, that is our step number 1. Create a cluster in the GKE, in the GCP, which is GKE. Step number 2 would be, we'll upload our code to Google Cloud. Step number 3 would be, we create container image. Remember, we are deploying containers, so we'll create container image of our application. Step number 4 is, we will push container image to GCR, which is the Google Container Registry. Remember, what is the concept of the registry? It can hold your container images. Step number 5 is deploy our application from GCR to GKE cluster. Deploy our application from GCR to GKE cluster. Let's do these steps. So we have already in the step number 1, we have done that. We have created the clusters. Meanwhile, I will work for the step number 2. So Google has this functionality which is known as Cloud Shell, by which it is behind the scene a virtual machine only. So you upload your code base on this Cloud Shell on this virtual machine, and then this virtual machine you can create your containers as well. You can create your container images. This virtual machine is already having Docker on it. So I'll upload my code. My code is there in these 3 files. I'm going to upload these 3 files here. But I can upload the complete folder as well. So I will upload my code here, upload folder. So now all the 3 files are there in the Google Cloud Console. I can, see my files are there. That means we have done step number 2, upload our code to the Google Cloud. Now we are in the step number 3. We have to create container image on this application. Now on this Cloud Shell, if I type Docker -- version, it will tell me whether Docker is present on this machine or not. And yes, we can see Docker version 24.07. That means Docker is present on this machine. If I do Docker space images, now these are the commands. Now this command we have already seen on my local machine. It can tell me what all container images are there. By default, there is nothing. So I'm going to create my container image from scratch. So here I'm giving the name of the container image as Kubernetes first app. Now, if I do Docker space images, I can see my Kubernetes first app is created. The application code is, if I do cat docker _first_app.py file, You can see it is /welcome 3000. Then I'm going to tag as per my project. This is required in order to push your image to your container registry. So Docker tag means you have just given another name to the same image. You can see this is my earlier image. Now there is one more entry here, and these two are pointing to the same image ID. That means it's just another name that I have given as per my, when I have to push my image to the registry, it has to have some format. And this is that format gcr.io, your project ID, then your app, which is Kubernetes underscore first app. Then I have to configure my Docker to connect to GCR. And now I'm going to push my image to the container registry. Now, once my image is pushed in the container registry, that means we are done with step number 3. That means the create container image of our application and push our container image to GCR. Now, step number 4 is also done. It's time to test our step number 5. That means deploy your application from GCR to GK cluster now. At this point, you can see your cluster is created. The name of the cluster that I created was cluster 1. It was already there. The dev cluster was already there. Now I have created cluster 1. I can deploy this application from the UI, my application on the GCP console. We have this workload. Workload tells me, what all applications you have deployed on your GK cluster. Right now, there is no application. Nothing is there. But I'm going to create my first application in the GK, which is the same application that I ran on my local machine using the Docker. I'm going to deploy that now on the Kubernetes. So if I click on create deployment, I have to give the image. I will choose here. I will go to the container registry. Here you can see my image is there. This is my image. Kubernetes first app that I pushed to the GCR. I will scroll down. So continue. Just give the name to my, I would say, my first app. And this is the cluster I'm going to deploy, and I will say deploy. What will happen is by default, when by design, when you deploy your application via UI of the GCP, of the GKE, you will see that there would be 3 instances of your application that will be deployed on the Kubernetes cluster. So there are 3 instances of your applications that are running. I can go inside these 3 instances as well. I will use the command line utility to show you where these applications are deployed. And I can go inside my application also within the Kubernetes, and I can run my curl command as well to test my application is running perfectly fine or not. Kubernetes has a command line utility which is known as kubectl. By this command line utility, you can connect to your cluster, and then you can run the commands by which you can go inside the running containers inside your application. You can test your application. You can deploy your application from that command line utility. So I'm going to use that command line utility. For that, I have to first connect to my cluster. We have to copy it again. If I do kubectl get nodes, this will tell me what all nodes do we have, how many number of machines we do have in this cluster. There are 2 worker nodes. If I want to see what all applications are deployed in my cluster, I would use something known as kubectl get pods. So there are 3 pods that are running for my application. So 3 instances are running. If I do a command like kubectl get pods -o space wide, this will give me a few more information about like this instance is running on what machine. For example, you can see the first instance is running on this machine that is ending with 117G. This is the machine on which this is running. Then the second instance is running on another machine and Q3X. Then the third one is running again on the first one. And that's what I created in the diagram. It might be possible that, in your multiple microservices, they may be running on the different machines, quite possible. And that's what you can see. I have 3 instances of the same microservice, and there are 2 machines. And you can see they're segregated here. But think about a complicated scenario wherein you may have 30, 40 microservices running across 5, 6 machines. In that case, you don't have to go to the worker node and see whether your application is running. Everything can be managed by the Kubernetes directly. All you need to do is just run these commands and you can see what is the state of your application. Now let's test our application. I can go inside my application as well. Let me go in the first instance. To go inside the first instance, I'm going to use a command using the kubectl. For example, I will say kubectl exec -it. Now this is the command syntax. In order to go inside an application in Kubernetes, you will say kubectl exec -it. You give the application ID here. Then let's say --bin/sh. You are right now within your application. If I do a ps command, now ps stands for give me all the processors that is running. You can see my application is running. Docker first app is running. I'm running this ps command within a container, within a pod that is running on this Kubernetes. I'm running that command. I can also test my application here. If I say apk add curl, this will install curl within this pod. And if I do curl localhost :3000/welcome, you can see I'm getting an output. Welcome to container world. So what I have done is I went inside one of the containers and then I am testing my application is running perfectly fine or not. I can come out of it, come out of the first application instance. Now I will go inside the second one. So I'll use the same command, just I have to change the instance ID here. Again, I would install the curl utility. Now if I do curl localhost :3000/welcome, I can see this output as well. Welcome to container world. What about I want to expose my application to the whole world? Right now, I can only access my application within, once I went inside the instance, then and only then I'm testing my application. What about I have to expose my application to the whole world so that you guys can also send a request? I can also do that. I will just expose my application to the whole world. To do that, I will go to the option in the UI by which I can expose my application. My target port is 3000. That's what, that's the port in my application on which it is listening. I will say expose. So we'll wait for this, to have an IP address of my application so that you guys can also access it from your machine as well. Still not yet done. And now you can see I got an external IP. If I take this external IP and just say /welcome, you can see I'm getting an output. Welcome to container world. And I want you guys to also try this URL in your browser. Just go and hit this URL in your browser. Hit the URL that I have given you in the browser and let me know whether you are able to see the response or not. You should also be able to see the response. I could see a yes from Himanshu. It's great. What about others? Anyone else who has tried this? Yes, Aditya is saying yes, Soman is saying yes, that's great. So now I have exposed my application to the whole world. Earlier, it was just running on the Kubernetes cluster. I can only access it. Now I could see you people can also access it from your machines as well. So this is how you can deploy your application, you containerize application and microservice on a Google Cloud platform in Kubernetes. So this is now, I will conclude my demo part. So I'll just, again, talk about what we, discussed. We talked about containerization. How do you convert your application, traditional application into a containerized application? Then what is the microservices? What is the use cases of, microservices, how it is beneficial? Then how this can get complicated if you have multiple microservices, you have to manage them across multiple machines. And then we talked about Kubernetes. How do you deploy your application in the Kubernetes? We have seen that as well. And finally, we went inside the application that is running in the Kubernetes. We tested that. And then also we exposed that application on the Kubernetes. All right, so that is all that I have. And also I talked about where are the different services you can have on which you can run your Kubernetes application. I will give the session, request to Rupali. She will take it further from here. And then at the end, we will take question and answers as well. So I'll be here till the end, don't worry. So Rupali, over to you.
Yes, thank you, Parth. Thanks a lot. Thank you for such an insightful session. I'm sure the participants will definitely, find this very helpful. So now, let me just share my screen. Is my screen visible?
Yeah, we can see it.
Yeah. All right. So, Parth has already given us a very good overview of the whole, app deployment, containerization and all. But, we have much more in store, including this, we have much more in store with our program. So if any one of you is, interested in getting end-to-end information about how things operate in Google Cloud, how the architecture is done. So certainly this program is for you. So we at SkillUp Online, we present this program, Google Cloud Architecture program, that covers everything right from solutions engineering to infrastructure management in this program. So let's dive into the Google Cloud Architect program. So this is a comprehensive journey that's designed to equip you with the skills that you require to become a Google Cloud Architect. Now, this program has been developed in collaboration with Google Cloud, and it is actually a unique partnership that sets us apart in the education and technology landscape. Now, what makes this program special is it's the exclusive access we provide to the learners. So our labs are equipped with copyright protected content directly from Google Cloud, offering an authentic glimpse into the live production environment of Google Cloud products. That means, you are not just simulating scenarios, you are actually navigating the real world challenges. So basically, all the hands-on labs that you get access to through this program are genuinely the live instances of the production environment of the Google products, right? So if we look at the structure of this program, so this program consists of three different courses which have been merged together. So this starts with the fundamentals of solutions engineering, where you get started with the Google Cloud Workspace Essentials. Then there's cloud function storage, data flow templates. We have compute engine, introduction to compute engine and how you work through the GKE. Then at level 2, you have cloud infrastructure management, where you learn about Google Cloud monitoring, virtual machines, BigQuery, then how projects are planned, deploying the projects. There's Kubernetes, there's cost optimization, managing cloud policies. And then the advanced level of this course covers computational intelligence and overview of the cloud security, where you are introduced to CI/CD, continuous delivery and load testing, auto scaling, then infrastructure provisioning, and the best practices in cloud security. Right, so this is just an overview that I wanted to give you about the whole learning path that this program covers. Right, so this program, which spans over 80 plus hours from beginner to advanced level, includes 11 lessons and 72 Google Quick Labs. Now, you will experience a hybrid immersive learning approach in this program with virtual instructor-led training sessions every weekend to provide in-depth insights. And we've designed the program to be, more of 60% of self-paced labs and 40% of industry expertise, ensuring a quite comprehensive learning experience. And once you complete this program, it grants you the job aligned hands-on practical training. We also offer you one-on-one mentoring support, access to industry-led human skills training. It also prepares you for the Google Professional Cloud Architect Certification exam, giving you a competitive edge in the industry. So we do have some upcoming cohorts for this program. So our next cohort is starting from 3rd of February. So anyone out there who's interested in having more information about this program, you can certainly fill in the feedback form that our team will be circulating in the chat. And if you're interested, just share your details and our team will get connected to you. I encourage all of you to fill the feedback form so that we can connect with you, right? We will also share this PPT with all of you, where you can, hear directly from our learners what they have to talk about the Google Cloud Architect program, how they have got placed, and how this program has helped them, go one step ahead in their career. So definitely you can go through these videos. So apart from this learning content, the additional support that you get from SkillUp Online is that after 15 days of program completion, you get some more, interactive sessions with our industry experts, with our instructor, with our mentoring team, where you can, have this refresher sessions where you can ask them anything in context to the content that has been covered in the course. Also, after 30 days of the program completion, you get another session uh, as a refresher. So it's not just about, when you are with us through your learning journey, even after the course completion, we still are there at your support to provide you with all the best of, assistance that we can provide. Now, it has been a long session. Let's just relax ourselves a bit, and let's look at the quiz. As I promised you in the beginning of the session, we will have this gamified challenge for all of you. So let's get ready for this gamified quiz. We also have an exciting reward for the winners of this quiz. So the top three contestants, the winners will not only showcase their knowledge, but will also receive a 25% discount coupon code if at all they are interested in, signing up for this Google Cloud Architect program. So get your thinking caps on and let the quiz begin. I hand over the charge to Ankur now. He will take you through this challenge.
Thank you
Over
very
to
much.
you, Ankur.
So, hope my screen is visible to everyone.
Yes, it is, Ankur.
Great. Thank you very much, Rupali. So, this is a gamification challenge, you can say. There will be 10 questions in this quiz. What you need to do is, first of all, on your laptops or on your mobile phones, you need to log in on www.kahoot.it, and it will ask you for the game pin, which is 71905. I'll repeat, on your laptops or on your mobile phones, log in on your browsers, write down www.kahoot.it, and it will ask you to put your name and then the game pin, which is 71905. I'll wait for some time for the participants to enter the game. There will be 10 questions. Each question will be having 20 seconds to answer. You need to look for the question on my screen, and after that you need to select the correct option at your device. If you're logged in on your laptop or on your mobile phone, you need to select the correct answer on your device. The quick you answer, the more points you get for the question. After all the questions, there will be 3 winners. And as Rupali already explained and already informed, the top 3 winners will be getting 25% discount for the program. So I'll wait for some time. I would request everyone to join the game. We can see Himanshu, Rupali, Anshu is there. We have 13 participants altogether. So I would request everyone to join. Please enter www.kahoot.it. You can scan the barcode as well. There's a QR code. You can scan this as well from your mobile phone. We have Suman also. Let's wait for 1 minute and then we'll start the quiz. The more quick you answer, more points you will get for the particular question. So this is the main point you need to keep in mind. Right, so let's start with the quiz. So the first question is, what are the 3 primary service models in cloud computing? You have 4 options in front of you. Look for the question on my screen and select the correct answer at your screen. 7 seconds left.
Sorry, Ankur, sorry for the interruption. What is the game pin?
I'll repeat once again.
Oh, so it's in the chat box 71905.
Right. So there was no correct answer. Let's move on to the next question. So no one has opened the scoreboard till now. Next question. What does
Ankur,
scalability
it's not
refer to?
working for me.
It's not-
Aditya.
Aditya, I'll just check. Shahid, can you just check the pin again? Is it the correct pin which you have
Yeah,
entered?
now I think I've got the second question.
Yes.
So it took directly to second question now.
Right. No worries. You can select the answer. Right. We have 4 correct answers this time. Let's see the scoreboard. Right. We have Suman on first position, Anshu on second, Rupali on third, and Himanshu on fourth position. I'll move on to the next question. Which technology is commonly used for containerization, facilitating the deployment of applications? Virtual machines, Docker, Java runtime environment, Apache web server. 10 seconds left. The quick you answer, more points you will be getting. Right? So you have 5 correct answers. The Docker. Let's see any change in the scoreboard or not. Right. Suman on first, Anshu remains on second, and Himanshu has moved on to the third position. Let's move on to the next question. What does a container image include? There are 4 options. Only the deployment configuration, execution environment and dependencies, only the application code, none of the above. Last 7 seconds left. Be quick. Okay, so time is up and 4 have given the correct answers. Let's see any change in the scoreboard or not. Right, scoreboard remains the same. Suman on first, Anshu on second, and Himanshu on third position. Let's see the next question. What does a container represent in Docker? A single process, set of services, an entire application, only a deployment configuration? I haven't got any answer. One answer now. 5 seconds. And the time is up. So no one gave the correct answer. The correct answer was a single process. Let's see, is there any change in the scoreboard? I don't think it will be there. Suman remains on the first position. Next question. What is the default registry for most public images? Google Cloud Registry, Docker Hub, Kubernetes Registry, Microservices Registry. Only one answer till now. We have 2 answers, 3 answers. Last 5 seconds left. And the time is up. So 3 gave the correct answer, Docker Hub. Let's see any change in the scoreboard. Suman still remains on first, Anshu on second, and Rupali has come to the third position now. The next question. What defines microservices architecture? 4 answers in front of you. Please select the correct answer to get more points. 10 seconds left. We haven't got any answer till now. Yes, now we have got 3 answers. 4 answers. And the time is up. So no one gave the correct answer though. There won't be any change in the scoreboard. Let's go to the next question. Why are microservices preferred over monolithic projects? Easier management of deployable components, larger team collaborations, uniform tools and frameworks, no drawbacks. Only 2 answers till now. Last. All right, the time is up now. All right, so 3 people gave the correct answer. Let's see the scoreboard. Right, Suman has moved to, Suman is still on first. Himanshu has come to the second position. And Anshu is on third position now. So this is the second last question. How does the size of the cluster impact the deployment of applications with Kubernetes? 4 options. Be quick to answer the question on your device. No answer till now. 10 seconds are over. All right. 2 answers, 3 answers now. Okay, so only one person has given the correct answer. Let's see the score change in scoreboard or not. Right, so there is no change. So this will be the last question now, the 10th question. How does microservices typically communicate with each other? Through heavyweight protocols, over messaging or HTTP, using synchronous methods, directly without any protocols. Right, last 7 seconds left. We got only 4 answers. And the time is up. So 2 gave the correct answer. Let's see the podium now. Who is on the third, second, and first position with runner-ups? So the third position goes to Rupali. Congratulations, Rupali. Second position to Himanshu. And first position goes to Suman. That was a great change. Congratulations, Suman, Himanshu, and Rupali. Right. Over to you, Rupali.
All right. Thanks, Ankush. Thanks for hello. Hello.
Yes, yeah, Rupali.
Yeah, am I audible?
Yes, you are audible.
Yes. All right. Thanks a lot, Ankur, for hosting this gamified quiz. And congratulations, Suman. So, as we promised, we are giving you this discount coupon for Google Cloud Architect program. You will soon receive the details in your inbox. So, please look for it, right? With this, we are almost coming to the end of the session. I now open the forum for Q&A, if any. If any of you has any questions for Mr. Parth, you may please go ahead and ask. Any questions? Suman, Anshu, Sachin, any questions? Any questions, guys? Please feel free to ask questions in case you have. All right, so no questions, I guess. Okay, so I think we are good to wrap up with this session. Thank you.
Just one question, Rupali. So would you
Yeah.
be sharing the link to download this session?
Yes, Aditya. We'll share the link with you.
Okay. Thank you so much, Rupali, for arranging this.
You're welcome, Aditya. So a big thank you to Mr. Parth for enlightening our participants with this knowledge. Thank you very much for being a part of this journey. I thank all the participants for making time to attend this session. And we are certainly excited about the knowledge and experiences that you all have gained today. And sure, this is going to help you in your cloud journey ahead. So once again, thanks a lot for being a part of this session.
I would like to thank you everyone here, those who have joined us, for your time. This doesn't mean that we cannot get connected, next time. If you have still some questions, some queries regarding the course, how this is going to get happen, all the minute details, you can still get back to us anytime via email, via phone numbers are already there. Let us know you have some queries. You can directly connect to your trainers. You can connect to your, all the facilitators here. Anyone having still any question, you can let us know. Hope to see you soon, guys.
Thank you, Parth. Thank you, everyone.
Thank you, everyone.
Thank you.
Thank you to everyone.